Hey, sixth graders! We have a little bit of a different format for this lesson today because we are kind of moving into some different type of investigation and some hands-on activities. I'm not even sure why my video is not showing in this, but we're going to start class here by watching this short little clip video about geologists and GPS and rate of motion. And then we are going to move into our activity where we are going to look at the rate at which the plates are moving in our world.
Geologists use GPS, or Global Positioning System, to track the motion of Earth's plates. You might be familiar with GPS because smartphones and many cars have built-in GPS receivers. They can work with mapping applications to show you where you are at any time, so you might never be lost again. GPS requires two parts, a receiver on Earth and satellites in space that send radio signals to the receiver. Once your receiver gets signals from at least 3 different satellites, it can accurately calculate your position on Earth. And if your receiver moves, the GPS system can measure the exact speed and distance you've traveled. This kind of accuracy makes GPS really useful for geologists who study plate motion. Plates only move a few centimeters per year, which is very hard to see, but using GPS, they can easily measure how much the plates are moving. Geologists can install permanent GPS stations into rock on the Earth's surface to track how much the plates move over time. This GPS station is not in the same spot it was a year ago, but we can only tell because the GPS receiver was able to measure the tiny amount of movement that happened. Plates move such a small distance each year that it's not really visible to our eyes. But as the GPS receivers continue to move, geologists can measure these very tiny movements over time. The readings can measure exactly how fast the plates are moving and in what direction. So even though we can't observe plates moving with our eyes, geologists can study them using accurate and reliable GPS data.
All right, so I realized that my video was in that entire time, and I apologize for some of the weird faces that I made, but that was some cool information that we learned about GPSs and how scientists use GPS to track the motion of plate movement, so we can really see that they're sticking these things right into the rock, and they come back and they use that GPS data in order to gather information about what kind of motion the plates are having. So today you are going to use a similar concept in your should do assignment. You are going to be able to stick some of those GPS data right into some continents in the simulator. And then in this activity, you are going to be kind of looking at what that travel is, what that rate of travel looks like. So what you're going to do is you're going to cut the blank boundary map on the single lines, and then you're going to use the key to identify the type of boundary. You're going to use a ruler to measure the distance a plate would move in 1 year, and then you're going to glue your pages back together. We're going to go through this all right now. So you're going to get a piece of paper that looks like this. You're going to cut this paper, not this one. Okay, only cut the one that is completely black and white with the lines, with the black lines. You're going to cut all of these black lines, which are the plate boundaries. And as you cut them, you are going to have a big map of cut up plate boundaries that we are going to look at and kind of put back together in a new way. So remember that your scraps at this time, after you've cut them up, they should go in the recycling. And then you're going to get your ruler. So you are going to have pieces that look like this. You're going to have all of these plate pieces on your page, and you are going to use your plate movement map to kind of figure out what the movement would be. So if you look at the key, we can see it says that the rate at which a plate moves per year is the numbers that are on here. So we can see that the plates are moving this many centimeters per year. So you're going to find these plate boundaries, and you're going to match them up with your map, and you're going to see what that distance is and measure it and re-glue your paper. It'll look something like this. So you're going to have your pieces, you're going to put these pieces back together like a puzzle. Then you're going to get your ruler, and I'm zoomed in over here so I can kind of see. So I can see that this piece here on the left is this plate over here, and this plate over here on the right is this plate over here on the right. And I see that it is a divergent, so they're moving apart, boundary that is moving 3 centimeters per year. So as I see the number 3, so 3 centimeters per year at a divergent boundary and moving apart. So that means I need to move these pieces of plate 3 centimeters apart. And so I look at my ruler, I have the numbers I count 1, 2, 3 centimeters, and then I'm going to move them that far apart, and then I'm going to glue them down. Then I'm going to find my next piece, and I'm going to identify what the distance is, or the movement is at those boundary types, and I'm going to glue those down. Remember that we have both divergent away and convergent towards, so we might have some pages that overlap, and we might have some pages that now have gaps. Remember that just because there's a gap underneath with the paper, that does not mean that there's a gap in the earth. It just means that is kind of, we're representing what that would look like or how much it's moving in a year, and that is filled in with the mantle and becomes hard, solid rock. All right, remember that when you're done, you should turn in your pages at the designated class drawer. So find the drawer that says your period number on it and make sure your name is on there, and then just stick it in that drawer for me to look at another time. I hope that you enjoy this activity and that you learn just a little bit more about the rate at which plates are moving. And remember, today is a great day to learn. Happy learning!